Hey guys, my name is Rohit Gupta and today in this video we are going to learn about how to implement stacks using linked list. So, what is a stack? A stack is a basic data structure that can be logically thought of as a linear structure represented by the real world physical stack or pile. A structure where insertion and deletion of items takes place at one end called top of the stack. The basic concept can be illustrated by thinking of your data set as a stack of plates or book, where you can only take the top item of the stack in order to remove things from it. So, what is a linked list? A simple real life example is a train. Here, each coach is connected to its previous and the next coach. In terms of programming language, consider the coach body as node value and the connectors as links to the previous and the next nodes. Why we need to learn stacks using linked list? First, it's dynamic. Second, it's mutable, that is, the values of it can be changed later. And third, it's space complexity. That means the space required by the algorithm does not grow with the input or the size of the data on which we are using the algorithm.
So hello friends, I am Darshan Chheda and we will see today how to insert data in a stack. So we have created a function called as push which we will use to insert data in a stack. So let us check our very first program or very first operation on stacks, that is push. Push as in inserting a data into a stack. So as we have discussed earlier that stacks are LIFO, that is last in and first out. So let us focus on inserting data. So we can see that before pushing the data into the stack or before pushing the data into the linked list was C, B and A. But as soon as a new data is pushed into the stack, the linked list is D, C, B and A. So how does this happen? The basic algorithm behind pushing a data or inserting a data into a stack is, first, take the data input to be inserted from the user. Now check whether the stack is empty or not. If stack is empty, allocate some memory for the head node. In our program, we have used a top pointer for head node. Enter the data in this head node and point the node to the null. Else, if stack is not empty, make the head node as the second node, allocate memory for the first node, take data input over there and point it to the second node. Now again, make that first node as the head node. As simple as that. Let us see our program that we have written. So our program is a menu driven program. As soon as we press 1, the push function would be called, and what it would do is it would check if top is null. If top is null, the top is the head node. If top is null, what it would do is allocate some memory for top and enter that value taken from the user into that top and point top next to null. Else, if the top or the stack is not empty, what we would do is create a temporary node, allocate some memory for it, enter the value into it and point it next to the first node of the stack that is already created and make that temporary node as the head node. As we can see over here, top equals to 10. So I hope you have understood the push.
Hello friends, I am Deep Dama and today I am going to talk about the pop function. The pop function is used to remove elements from the stack, and let's see how it's done. To delete an element from the stack data structure, we use the pop function. Stack is the last in first out data structure. That means the last element that goes in is the first element that is deleted. Therefore, when we are deleting a node from the stack data structure, the last element that has gone in will be the first to be deleted. This last element is pointed by the top pointer. Now, to delete this element, we create a new pointer. Let me call it as temp. Temp stores the same address as the top pointer and points to the latest element that has been added. Now to delete this element, we first increment the top pointer by using the code top is equal to top arrow next. Now top is pointing to the next element and not the last element. To delete the last element, we free temp by using the code free bracket temp. The Memory, which was dynamically allocated for the node, has now been freed, and the latest element in the stack has been now deleted.
Hello friends, my name is Raj Doshi and now I'm going to explain peep and display function in stacks using linked list. So now let's jump to the code.
So peep function is very lucid and easy. In this function, we just have to display the data of the top element. But before that, we have to check whether the stack is empty or not. So in the if loop, first we will check if top equals null. If yes, then we will print underflow or nothing to display. Or else, we will print the data of the top element. So now coming to the display function, in stacks, we display element from top to bottom. So first thing we need to check is whether the stack is empty or not. So we will check the if loop which says if top equals null, we will print underflow or nothing to display. Or else we will assign temporary node to the top and traverse while printing the temporary data and go to the next node respectively. In this way, we will display all the elements in a stack one by one.
Hey guys, myself Sushant Gharal, and I'm going. Since up till now, you all have learned about the implementation of stacks using linked list in C programming language. Now let's learn about the output by taking an instance. Up till now, we have discussed the implementation of and logic of stacks using linked list. Now we will compile and run the program and execute the output implementing stacks. So here we have compiled and then run. As we can see, our program is menu driven with push, pop, peep and display being the key operations on stack. So first let's push few elements in our empty stack. As it is showing insertion is successful. Let's keep inserting few more elements. So here we have inserted enough elements. Now we will display all the elements. Here as we can see, we are having 6 elements in the stack with 66 being the topmost element. Now we will see what peep does. Peep function shows the topmost element of our stack. So here we are having 66 as the topmost element. So now by displaying again all the elements, we are having this. Now we will start popping all the elements. So deleted element 66. So basically we deleted topmost element 66 and the top pointer is now pointing to 49. So we'll keep popping further until we empty the stack. Deleted element 12. Now further, when we choose to pop, it shows stack is empty. Again by displaying, it will show stack is empty. In this way, we have implemented stacks using linked list. So now we will exit the program. Thank you.